Hello to all. So in this video, we will proceed with topic 9, differentiation. And for today, our first subtopic would be derivative of a function, where we want to find a derivative using first principle. Whenever you encounter a situation where you have to find a derivative by using a first principle, then you have to use a limit concept. Here, your formula would be f prime x will be equal to limit of h approaches 0 of f of x plus h minus fx divided by h, and this formula would be fixed. Let's do some exercises to check our understanding. So for example 1, we have to find the derivative, or we have to use a first principle of differentiation to find the derivative. So before we start, I just copy back our formula. So our f prime would be equal to limit of h approaches 0 of f of x plus h minus with fx divided by h. So our first function here is y. So the derivative of y, we have two options of symbol. You can use either y prime or dy dx, is up to you. Both are correct. Here I use a y prime, so y prime would be equal to limit of h approaches 0 of, first one is f of x plus h, so every single x you change into x plus h. Now we will have 3 of x plus h squared minus with 5 of x plus h plus 8. And then second one, we have to minus by fx. So fx is basically your original function, so you just have to copy it back. So 3x squared minus 5x plus 8. And all must be divided by h. So that's your first step. You just have to define your function using the concept of first principle. Next, we want to solve this situation. Same as before, we already learned that in order to solve a limit question, the first basic step is by using direct substitution. But here, if you directly substitute h approaches 0, so all h substitute with 0, you will encounter the case 0 over 0. So this is basically indeterminate case. Then you don't have any other choice but to simplify your function. So first step that I would do is basically expand all your bracket here. So here 3 of x plus h squared, I open up the bracket, so we will get 3x squared plus 6hx plus 3h squared. And then that would be minus with 5x minus 5h plus 8. And then I also open up the second bracket, so there would be minus 3x squared plus 5x minus 8. And all would be divided by h. Then try to simplify your equation now. Check whether anything can be cancelled out. So obviously here 3x squared can be cancelled out. Next one, 5x also can be cancelled out, and last one 8 also can be cancelled out. Then it seems more simple now. Okay, once again, if you directly try to substitute h equal to 0 into your function here, once again you will encounter 0 over 0 case. So that's not the answer yet, but we figure out that basically all the same terms, but basically we can detect that all the terms have the same factor of h. So we know now that we can factorize h outside. So this would be equal to limit of h approaches 0 of, we factorize h outside, so first term leave with 6x plus 3h minus 5 divided by h. Now obviously you can cancel out h, And last step, once again, try to substitute the limit value into your function. So we will get 6x plus 3 times 0 minus 5. And your final answer would be 6x minus 5. And that is basically how you find the derivative of your function by using first principle concept. Okay, now we try again with a different function. Before that, once again, I just copy back our formula. So f prime will be equal to limit of h approaches 0 of f of x plus h minus with fx divided by h. So now we want to find the derivative by using first principle of set of 8x minus 3. So derivative of fx will be f prime x here will be equal to, directly substitute into the formula. So we have limit of h approaches 0 of f of x plus h. Once again, substitute your x with x plus h. So here we will have set of 8 times x plus h minus 3 minus with our original function here. So that would be 8x minus 3 divided by h. Then try to substitute your limit value, and once again here actually if you try to substitute you will get 0 over 0 indeterminate case. And as before, try to simplify your function, but obviously there's nothing to simplify there. But we can detect now here we have a surd function. As you already learned in topic 8, whenever you have a 0 over 0 case, partner with a surd function, we can multiply with conjugate of your surd. So now, the conjugate of our surd here would be surd of 8 of x plus h minus 3 plus with surd of 8x minus 3. And since the numerator part we already multiply with it, so denominator part must be multiplied with the same conjugate function. Okay, now try to expand. Remember, you just have to expand your partner conjugate. So obviously here you just have to expand your numerator part, and denominator part you just have to copy it back. So I expand the first one, so we will get 8 of x plus h minus 3. And then for second one, surd, you get a plus, and then multiply the second one, the same function, but you get a negative sign, so I just don't have to write back. So this would be minus, the last one would be 8x minus 3. And for denominator part, you just have to copy everything back. So surd of 8x plus h minus 3 plus surd of 8x minus 3. Now try to open up your bracket and simplify everything that you can. So we will have 8x plus 8h minus 3 minus 8x plus 3. Once again, denominator part, you don't do anything but just copy it back, or else it will be too complicated and you will stop after that. So check if there is anything that you can cancel out. So obviously 8x you can cancel out, and 3 also you can cancel out. So now you can detect for numerator part you only have 8h, and for denominator part we have a common factor of h. So obviously h also can be cancelled out. Now just copy back your simplified version. So limit of h approaches 0 of, for numerator part we only have 8 there. Denominator part we have surd of 8x plus h minus 3 plus with surd of 8x minus 3. Now, last step, we can directly substitute h approaches 0 into our function. So we will get 8 divided by surd of 8x minus 3 plus surd of 8x minus 3. We get a same variable or terms here, so that one can be simplified. So 8 divided by 2 of surd of 8x minus 3. This one also once again can be simplified, so our final answer will be 4 divided by surd of 8x minus 3. Now let's proceed to example 2. By using the first principle of differentiation, we have to find the first derivative of f(x) equal to 8 over 5 minus x at x equal to 13. So first step, we have to find the derivative using concept of first principle. So now f prime x will be equal to limit of h approaches 0 of 8 over 5 minus with x plus h minus with 8 over 5 minus x, the whole thing divided by h. Since our equation look a little bit complicated, now we have to try to simplify our function. So this would be equal to limit of h approaches 0. Now for denominator part, since we have only h term there, so I will factorize it outside. So we will have 1 over h times with, now for numerator part, since we have two different fractions there, I will perform cross multiply to transform this into one fraction only. So we will have 8 times with 5 minus x minus with 8 times with 5 minus x plus h divided by, and then for numerator part, we just have to copy everything back. So 5 minus x plus h times with 5 minus x. Next, we will open up all the bracket to simplify this. So limit of h approaches 0 of 1 over h. And then open up your bracket, so we will get 40 minus 8x minus 40 plus 8x plus 8h divided by, for numerator part, I just copy everything back. So 5 minus x plus h times with 5 minus x. Next, check if there is anything that we can cancel out. So obviously now 40 we can cancel out. 8x also can be cancelled out. And then since for numerator part we only have 8h and we have 1 over h outside, so we can cancel out h here. So if I rewrite this back, we will have limit of h approaches 0 of 8 over 5 minus x plus h times with 5 minus x. So now you can try to substitute limit value into your function. You will get 8 over 5 minus x times with 5 minus x, and this would be equal to 8 over 5 minus x squared, and that is the answer for derivative using first principle. But then we have to find this at 13. So f prime 13 would be equal to 8 over 5 minus 13 squared. So 8 over 8 squared, your final answer would be 1 over